What is up? Check this out. Friedrich in the wall unit, like a P-TAC, but we keep calling it V-TAC, so maybe that wasn't a typo. So it's a vertical unit in the wall, except for this is inverter, precision inverter. So board is bad, the fuses are blown. So I guess under warranty, they want me to try switching the board with another room. So let's taking out the old bad board first, just to kind of see how it comes off and to explore these units as I've not seen them. Very similar to like a Mitsubishi or LG unit. Line voltage comes in here. These two fuses are blown. They go through all the filters, probably more filters, and then they get a bunch of diodes. And looks like they have a bunch of discrete diodes instead of a diode block. And probably right there. And then look at this, MOSFETs. Instead of an IGBT, it looks like it's all discrete MOSFETs. Look at that. 1, 2, 3, 4, 5, 6. That's what an IGBT is on the inside. It's 6 MOSFETs, isolated gate bipolar transistors. Looks like I dropped some screws. Better make sure I find those. But so there was a lot of screws, one for each discrete diode or MOSFET. So, and then it came off, and it has these insulators, which some of it started peeling. Like you do on an LG or Mitsubishi, they give you a board, and you have the bare bones electronics, and you put heatsink paste on it, and you screw those suckers down to the heatsink. I'm kind of thinking that this heatsink block has all these Allens on it. It's meant to come off with the board. So I'm going to take that off next. But anyway, before I do that, we can already see what's blown here. One of the diodes right there is shorted. Boom. Arced through right there. And the kind of funny thing is, I was kind of wondering if it actually didn't blow the diode, but it just wore through the insulator there to the heatsink and blown the fuses. The electronics might actually be good. I might be able to just put, if it was me, fix the insulator, put new insulators on those, replace the 2 fuses, and boom. Oh yeah, look at this SD card. I guess that's an easy way to put your program into them. So I'm gonna go ahead and get my tools out. Pull out those Allen screws there. Okay, pulled out all the metric Allen screws from the perimeter here. And indeed, this is just an air-to-air cooled heatsink. It's a big one, but it doesn't use refrigerant, it's just air. And yeah, when they ship this, they probably give you a circuit board already mounted on here. So look at that, that suction went through there. Right there. Normally you wouldn't get to see what happened there. Focus. Yeah, so yeah, it arced through. You see the insulator just failed. So one of the diodes, which will be, the middle one's probably the conductor. It probably just went AC line voltage right there. Boom. To ground. That's what happened. Probably nothing wrong with the rest of those electronics, but you never know. Okay, that part right there, C3D16060. I looked it up. I'll put it up on the screen. It is a diode. Yeah, so 4 of them right there. Probably one right here for another separate DC bus. These, if I haven't bent them up to look, but they might be full wave diode packs there too for another circuit. They don't have the metal on the back, so they're probably low current. Oh, in fact, they are diode packs. I see that squared off there. You see this edge right here, that's a polarity indicator for diode packs like that. And then these should be MOSFETs, but I peeled a pair up and I couldn't. The silicone all smeared on everything, even over the numbers. Okay, there's the old board, and I picked up the new board. Actually, sure enough, it comes with the heatsink. I wanted to make sure I got sat down and grounded myself before I opened this. That's huge. Ooh, smells brand new. Yeah, let's get some light on this. All right. So this is the top. Take a peek in there. I can still see these in the same style insulators. All the strips rather than each individual Formica one. So, just comes as one piece, just with a gasket right there, and just gets air cooled by the hot condenser air. And let's see, looking at the fan, it actually is whatever temperature ambient is, because I can see by scoops of the fan that the air pushes out, draws in at the top. Oh, what a marvelous design. It's drawing the cool air from on top and blow out the hot air right underneath it. From what I understand, they're already having recirculation issues on these here in the Arizona desert, which also makes these inverter boards work really hard. So, okay, got it plugged in. There's actually not that many wires to have to plug in. You got your line input and ground. Compressor output from the, and it's labeled red, blue, black. Outdoor fan. It says indoor fan, but nothing was plugged into that one. So it might be an ECM or something that's controlled separately. And then you have this data communication going between the two circuit boards. Call it PVHP1 14 16. Watch for sparks. Boom. So hopefully it's okay to connect this while it's running. Leave this one in like that. Ooh, man, that's a colorful, bright controller here. Must be locked out. I've never used one of these before. And indeed, I hear the compressor ramping up. And it's true VRF style. Costs a little 4.5 amps. Bunch of diagnostic lights flashing all over the place. There. Blowing out 52-degree air. Room is down to 77 degrees. Sweet. So I guess these aren't called P-TACs. They are called V-TACs. Interesting.